Hi, my name is Caroline González-Vega, and I recently completed my PhD work with Dr. Stein at the University of Illinois. And today I have the pleasure to talk about the digestible calcium requirements for 25 to 50 kilogram pigs. The objective of this study was to determine the requirement for a standardized total tract digestible calcium needed to maximize average daily gain, gain-to-feed ratio, bone ash, calcium retention at different concentrations of a standardized total tract digestible phosphorus. For this study, we used 20 diets. We had 5 different concentrations of total calcium from 0.18 to 1.14%, which corresponds from 30 to 170% of the NRC requirement. These diets were based on corn, soybean meal, calcium carbonate, and monocalcium phosphate, and because we previously determined the standardized total tract digestibility of calcium in these ingredients, we were able to calculate the standardized total tract digestible calcium in these diets. These values range from 0.13 to 0.72%. We had also 4 different concentrations of standardized total tract digestible phosphorus from 0.15 to 0.47%, which corresponds from 50 to 150% NRC requirement. These are the standardized total tract digestible calcium and standardized total tract digestible phosphorus ratios of the diets. It ranged from 0.28 to 1 to 4.8 to 1. The NRC requirements of calcium for the 25 to 50 kilogram pigs is 0.66%, and the NRC requirement of a standardized total tract digestible phosphorus is 0.31%, which corresponds to a ratio of a standardized total tract digestible calcium and a standardized total tract digestible phosphorus of 1.35 to 1. The same batch of diets were used for 2 different experiments. One experiment was a growth performance study that was conducted in 28 days, and we had 2 pigs per pen, 1 gilt and 1 barrow. On day 28, barrows were slaughtered to collect the right femurs to measure bone ash. The second experiment was a balance study. Pigs were housed individually in metabolism cages for 13 days, and fecal and urine samples were collected using the marker-to-marker approach. Now let's move into the results. This is a response surface model of the 20 diets. On the x-axis, we have the concentration of standardized total tract digestible calcium. On the y-axis, we have the variable. The red line represents the diets containing 0.15% digestible phosphorus. The black line represents the diets containing 0.31% digestible phosphorus. The blue line represents the diets containing 0.39% digestible phosphorus, and the green line represents the diets containing 0.47% digestible phosphorus. From this slide, we can observe that at low concentrations of a standardized total tract digestible calcium, the average daily gain was not very affected by the concentration of a standardized total tract digestible phosphorus. However, if diets contain 0.42% digestible calcium, there was a negative effect on the average daily gain for the diet containing 0.15% digestible phosphorus, but little difference was observed for the diets containing 0.31, 0.39, and 0.47% digestible phosphorus. If diets contain high concentrations of calcium, it results in an advantage to have more digestible phosphorus in the diets to reduce the negative effect on the average daily gain. On the right, we observe the pigs that were fed the diets containing 0.47% digestible phosphorus, and on the left, we have the pigs that were fed diets containing 0.15% digestible phosphorus. So you can see the difference in the body weight gain. This is the gain to feed ratio, and here we observe that at low concentration of digestible calcium, the gain to feed ratio was not very affected by the concentration of digestible phosphorus. However, if diets contain 0.42% digestible calcium, we observe a negative effect on the gain to feed ratio for the diets containing 0.15% digestible phosphorus, but little difference was observed for the diets containing 0.31, 0.39, and 0.47% digestible phosphorus. If diets contain high concentrations of calcium, it results in an advantage to have more digestible phosphorus in the diets to reduce the negative effect on the gain to feed ratio. This is the bone ash in grams, and at low concentration of calcium, we observed that bone ash was not very affected by the concentration of digestible phosphorus. However, if diets contain 0.42% digestible calcium, the bone ash was negatively affected in diets containing 0.15% digestible phosphorus, but little difference was observed for the diets containing 0.31, 0.39, and 0.47% digestible phosphorus. If diets contain high concentrations of calcium, it results in an advantage to have more digestible phosphorus in the diets to reduce the negative effect on the bone ash. This is the retention of calcium in the body, and we observe that there is no difference at low concentrations of digestible calcium regardless of the digestible phosphorus concentration. If diets contain 0.42% digestible calcium, we start to see a difference in the retention of calcium, and it increases as we increase the digestible phosphorus concentration. But at high concentrations of digestible calcium, it results in greater retention of calcium if we have greater concentrations of digestible phosphorus. This is a summary of the digestible calcium-digestible phosphorus ratio needed to maximize average daily gain, gain to feed ratio, bone ash, and calcium retention at the different concentrations of digestible phosphorus. To maximize growth performance, we recommend, if diets are formulated containing from 0.31 to 0.47% digestible phosphorus, to use a digestible calcium-digestible phosphorus ratio between 1.16 to 1 and 1.43 to 1. For bone ash, a greater digestible calcium and digestible phosphorus ratio is needed. It ranges from 2.87 to 1 to 1.47 to 1. For calcium retention, the digestible calcium and digestible phosphorus ratio is greater than the ratio needed to maximize bone ash. This ratio ranges from 5.07 to 1 to 2.36 to 1. It has been reported that the calcium-phosphorus ratio in the empty body weight of 50 kilogram pigs is between 1.25 to 1 and 1.70 to 1. We see that these ratios were similar to the ratios needed to maximize bone ash when pigs were fed between 0.31 and 0.47% digestible phosphorus. In conclusion, digestible calcium and digestible phosphorus ratio needed to maximize calcium retention is greater than the ratio needed to maximize bone ash. But further research needs to be conducted to elucidate where the extra calcium is being deposited if it's not in the bones. The digestible calcium and digestible phosphorus ratio needed to maximize bone ash is greater than the ratio needed to maximize growth performance. And we have to take into consideration that these greater ratios will negatively affect the growth performance. Therefore, the digestible calcium and digestible phosphorus ratio needed to maximize growth performance. If the digestible phosphorus is below the requirement by NRC, this ratio should be between 0.60 to 1 and 0.80 to 1. But if the digestible phosphorus meets or exceeds the NRC requirement, the digestible calcium and digestible phosphorus ratio should be between 1.16 to 1 and 1.43 to 1. The implications of this study are that diets fed to pigs should be formulated based on digestible calcium and digestible phosphorus, and to optimize growth performance, diets should contain digestible calcium and digestible phosphorus ratio between 1.15 to 1 and 1.45 to 1. Thank you for your attention, and also we want to acknowledge AB Vista for the financial support. And if you want to see more about this research or other related topics, you can visit our website, nutrition.nsi.illinois.edu. Thank you again. Bye.